Good morning. So today's topic is mechanical properties of dental materials. As an introduction, why we are learning the mechanical properties of dental materials, that you should be remembering in oral environment, that if you are giving a crown or any restoration or any orthodontic appliances, these restoration or the external appliance which you are giving will be exposed to chemical or thermal or mechanical challenges. These challenges can deform the material. So we should be knowing the mechanical properties of the material before which we introduce into the patient's mouth, so that we will know how that material will respond to that particular change which is happening in the patient's mouth. So mechanical properties are measured responses. They can be either plastic, they can be elastic. So elastic responses are reversible. On force removable, it will come back to its original form. And plastic responses are irreversible responses. That is, once we have applied the force, during the applied force, that material will change its form or change its shape, but it won't return back to its original position once the force is removed. That is plastic deformation. Plastic deformation is an irreversible change or a permanent deformation. Okay, so these two things you should be keeping in mind. That is elastic deformation and plastic deformation. So these elastic deformation are under elastic deformation there is proportional limit, resilience, modulus of elasticity. Under plastic deformation there is percentage of elongation, and there's combination of both, which is yield strength and toughness. These in detail we'll be discussing in the further slides. Okay. So before moving deeper into the chapter, we should be knowing what is force, what is stress, what is strain. Okay, force, which we all have studied in physics. What is a force? Force is nothing but any influence that can cause an object to undergo certain changes, like either it can be movements of the material or a change in direction of the material or geometric construction, changing its form. Okay, that is force. What is force? You should be keeping in mind. A force is defined in three characteristics. That is point of application of the force, magnitude, how much force we are applying, and the direction of force. Point of application is force is same amount of force. Suppose if we are applying 100 Newton of force, we all know the unit of force is Newton. If you are applying 100 Newton of force to a particular, suppose this pen, if you are applying 100 Newton of force, certain unit of force we are applying in the tip of the pen, which is different, and body middle of the pen, it is different, and at the here, if you are applying the force, it is different. If the pen is fixed to a bottom part of the pen is fixed, suppose if you are fixing the pen to a certain object at the bottom, the force which you are applying at the tip, middle, and bottom, both all the three times, that movement will be different. That is point of application of force. Depending on the force, the movement will be different. And magnitude of force. Magnitude of application of force is nothing but how much force we are applying to a particular object, so that the object will move. Especially in orthodontics, we should be applying a certain amount of force, which should not be deforming the material. This should not cause any too much of pain to the patient. If you are giving an orthodontic wire, during tightening of the wire, we should not be tightening it too much, so that patient will experience so much of pain. So magnitude of force we should be keeping in mind. And direction of force, which direction which you are applying the force, that also will influence the change of the material or change in form or shape or direction of movement of the material. Suppose if you are applying same amount of force, suppose 100 Newton of force which you are applying to an object which is in an inclined plane, that is in a slope, it is different. In an upward hill, the same amount of force which you are applying, it is different. And in a parallel plane, smooth plane, which if you are applying the same amount of force, the movement of the material will be different. In an uphill, that material is to move lesser. If you are applying the same 100 Newton force, which are needed to move the material in a same parallel plane, the material will be moving faster. But in a upward hill, if you are applying the same 100 Newton force, the movement patient material might not even move. That is the direction of force, which direction which you are applying force. That also we should keep in mind. Okay. Coming to the occlusal forces. In dentistry, we are mostly discussing about the occlusal forces acting inside our oral cavity. So maximum the average force which is acting in the oral cavity is about 200 to 350 Newton. Okay, in natural tooth it is 200 to 350 Newton. So occlusal force in adult teeth is highest in the posterior region, that is closest to the mandibular hinge axis. Mandibular hinge axis is nothing but the imaginary axis which is closing, joining the two temporomandibular joints, that you should be keeping in mind. So occlusal force in adult is the highest in the posterior region, that is closest to the hinge axis, that is closest to the temporomandibular joint. So most of the force, the highest amount of force will be acting in the molar region. And second, it will be as we are moving further, that is anteriorly, the force will again compared to molars, force acting on premolars will be lesser. And again anteriorly if you are moving, that is incisors if you are coming compared to premolars, it will be again lesser force acting on the incisor region. And these occlusal forces acting in the human teeth, we can compare it to a nutcracker, the same mechanism, nutcracker mechanism. That is, as shown in the image, that joint nut will be kept between the nutcracker, which is closest to the joint. There will be the force will be more in the near to the joint. The same way, occlusal force will be near to the more closer to the temporomandibular joint, that you should be keeping in mind. As you are moving anteriorly, force will be less in posterior most region, that is which is closest to the temporomandibular joint, that is the hinge axis. It will be force will be more compared to anterior. Coming to stress and strain. Stress is nothing but any internal resistance to resistance of a material to an external load applied to that particular material. So it is same as Newton's third law. For any applied force, there is unequal and opposite reaction. That is, so always when we are measuring the stress in oral cavity, we should be knowing how much stress that particular amount of particular restoration can withstand. So that we can apply if 200 Newton of force is applying into that particular amount of material, that material should be strong enough to withstand that amount of stress. Okay, that is the main purpose of studying this chapter. So stress is any internal resistance of a material to external applied load. So we won't be able to measure the internal resistance. So we should always measure the external load which we are applying. So stress is always, the measurement is always the external applied force which we will be measuring, because it will be difficult to measure the internal resistance, that material, how much internal resistance that material will be offering. So stress, measurement of the stress is always the external force which you are applying. Okay. So if you are giving in a descriptive manner, if you are defining it, it is the force per unit area acting on millions of atoms or molecules in a given plane of a material. So force acting per unit area. Stress is always, as a formula if you are making, it is the force per unit area. That is, force is expressed in Newton and area in meter square. So by a unit of the stress will be megapascal. Okay. So coming to the types of stresses, there are residual stress, structural stress. These you should be knowing the types of stress. You should be keeping in mind. What are the types of stress and how it is, where it is applied, how it is formed in a particular material. Okay. So residual stress is stress caused within the material during manufacturing process. Suppose during a welding of a wire or a rod, the stress which is developed in that rod will be residual stress. So structural stress is nothing but produced during function. Suppose a 3-unit FPD, masticatory forces acting on that FPD. So the stress which is developed, that force will be transferred directly onto the abutment tooth. That abutment tooth, the stress will be transferred directly to the abutment tooth. That is the structural stress, okay, produced during function. These are the examples of structural stress. And pressure stress is induced in vessels containing pressurized material. Vessels containing pressurized material, that is pressure stress. Example is during processing of a complete denture. Under pressure, we will be processing it under pressure, that is pressure stress. And flow stress is nothing but in dentistry, again, we will be fabricating crowns, SPD. Those times we have to melt the metal, and that molten alloy will be striking against the wall of a mold during casting. That time that stress developed against the wall is called the flow stress.